Hello, everyone. My name's Tim Bryce. I'm a forecaster with the National Weather Service in El Paso, and I'd like to thank you for joining us for day 3 of Monsoon Awareness Week. The last 2 days, we've had very good conversations. Monday, we talked about flash flooding. Last night, we had a great conversation about lightning and lightning safety. But for tonight, we're going to be talking about the monsoon threat of downbursts. And a lot of people get downbursts confused with tornadoes. They have very similar damage. They both come out of thunderstorms, and those can be a little confusing. And hopefully by the end of the night you can have a better understanding of the differences between a downburst, what is a microburst, what is a macroburst, and a tornado. We've got a full panel tonight. I'd like to introduce, first of all, John Fawcett. He's the warning coordination meteorologist at the El Paso office. John, how are you tonight?
I'm doing pretty good, Tim, and we have Lance Tripoli, one of our forecasters, our aviation focal point, who will join in from time to time.
Very good. Thanks for joining, Lance. Up in Albuquerque, we've got Carrie Jones, and Carrie Jones is the WCM, the Warning Coordination Meteorologist in Albuquerque, and we have as our guest panelist tonight Jim Reynolds, who's the MIC at the CWSU in Albuquerque. How are you guys doing?
We're doing well, Tim. How are you?
Good, good. Hey, Jim, real quickly, tell folks what a CWSU does and how it's quickly, how it's different than a forecast office.
You bet. So the Center Weather Service Unit is the small contingent of meteorologists within the FAA Air Traffic Control Center that gives direct weather support to the controllers, and we're there from like 6 in the morning until about 10 p.m., and we can give forecasts that range from lines of thunderstorms that will shut down basically what we call highways in the sky, all the way down to what's the weather going to be like when I'm off tomorrow and I'm going to go golfing. So whatever kind of direct weather support we need to give to the controllers, we do that.
I guess the way you kind of described it, you guys would be like the IMET for the aviation. You're on site giving them kind of direct support right in the FAA center.
Yes, you could say that because anybody can walk into the unit at any moment that we're on shift, and then vice versa, we can go down to any of the controllers at their positions at the scopes to give them information that will be relevant for their job.
Very good. Well, I want to thank you for joining us tonight, and I know you'll give us lots of good information about downburst. Moving west into Arizona, we've got Lee Carlisle, who's a forecaster at the weather. I almost said the Weather Channel at Tucson.
Well, it's TWC, so it's always possible.
I wrote down TWC, which is your 3-letter identifier, and I immediately thought the Weather Channel, but actually it is Tucson Forecast Office. How are you doing tonight, Lee?
Very well. Thanks for having me on, Tim. Appreciate it.
Not a problem. Heading up north, heading up into the mountains of Arizona, we've got Megan Schweitzer, who's a forecaster up there. How are you, Miss Megan?
Hi, doing good tonight. Finally enjoying some dry weather just in time for the start of monsoon season.
That's right. And I forgot to mention that yesterday and the day before we actually had thunderstorms going on in both Arizona and New Mexico. I think it's a little quieter in Arizona today, but I know that actually there's active weather going on in New Mexico this evening. So we got a little kind of an early start to the thunderstorm season here. Moving down into the Phoenix area, and actually, Jessica, can you kind of describe to people, Jessica's a forecaster there in Phoenix, can you describe what the Phoenix office covers? I think she walked away. Okay, so actually, people understand, Phoenix actually covers a big hunk, of course, southwest Arizona, but they actually grab a bit of, I guess you'd say, Southern California, the eastern part of Southern California. And then also joining us tonight is the warning coordination meteorologist from San Diego, Alex Tardy. How are you, Alex?
Hi, everyone. Thanks for having me on again. Third night in a row, and I'm in another location again. So tomorrow I'll have to see the broadcast from.
He's our musical panelist. We don't know where he's going to show up or at any time.
Alex, yeah.
All right. Well, thanks everyone for joining us. Let's get down to it. Let's start talking about downbursts. And like I was saying, I think people get downbursts confused with just regular winds out of a thunderstorm. You can get some strong gusty winds out of a thunderstorm or a tornado. And I'm going to turn things over to Jim right now. Jim, can you give us take as long as you want. While you're talking, I'm going to show the folks a video from Australia of a downburst that's going on. So if you can kind of define and let people know what a downburst is? That'd be great.
Sure, you bet, Tim. So a downburst is any strong downletting of either wind or rain, cool air, or rain that comes out of the bottom of the downdraft of a thunderstorm, which is definitely a lot different than a tornado. Typically, a downburst is going to have, again, the wind or the rain component that's going to hit the ground directly beneath the downdraft and then spread out in all directions. And so you're going to have pretty much a pattern of damage that may occur that's going to spread out in all directions from the point of impact on the ground where the rain or rain-cooled air hits. And so as you can see in the video here, you have a downburst here where you have a lot of rain coming down, and that's going to impact the ground and then spread out. We in the Weather Service have a tendency to pretty much give a categorization to just about every different kind of weather element, and we call a macro burst to be anything that's a downburst 2.5 miles wide or larger, and then a microburst is anything that's 2.5 miles or less than 2.5 miles in diameter from the point of impact. So what you're seeing in the video is probably just a microburst. It's not going to spread out more than 2.5 miles. But the incredible thing about these microbursts is that they can generate winds of up to easily 100 miles an hour, depending on the atmospheric conditions. So this, speaking from an aviation standpoint, like I would at work every day, very dangerous for aircraft that are on the ground or that are flying. And I think, Tim, you're going to show a video here in a little bit that shows an aircraft actually flying through one.
Yeah, so when we get a little further along here, we'll talk about different aspects of microbursts, and I do have an animation that I found on YouTube. I think it's from the Smithsonian channel of a simulation of what it's like for an airplane to go through. But Jim, the one way I've always kind of described the microburst in that case, and you can kind of see it there, was like you dropped a water balloon at the bottom of a thunderstorm. And then when it hits that ground, in case if you dropped a water balloon on the table, it would splat, and it would just spread out in all directions. Is that a good analogy to use when talking about, especially like a microburst?
Especially a wet microburst, I think that's a great analogy where you have just a real concentrated downletting of water for a wet microburst. Of course, the dry microburst is going to be more just rain or just rain-cooled air.
Right. So let's talk about, since we got a good definition of what a microburst is and a downburst. Lee, can you give us kind of an idea of how often we see these things? Where do they occur? What are the likely conditions for them to occur, especially over in Arizona's area?
Certainly, yeah, Tim. On average, each year, Arizona experiences about 30 what we call wind events, and this can be due to a downburst, a microburst, or just general outflow from a thunderstorm. But in terms of the southeastern part of Arizona, the Tucson area in particular, we almost have kind of two different seasons for microbursts. As Jim alluded to a little bit earlier, there's a dry and a wet microburst, and typically when we enter the monsoon season in June, there's not a whole lot of low-level moisture that's present. And so precipitation that falls through these clouds with bases that are just tremendously high up there, 15,000 feet or so, has a lot of time to evaporate. And by the time it gets to the ground, there's not a whole lot of rain there. So you get this big rush of wind when it smacks into the ground, but there's not a whole lot of precipitation. So that tends to be June and starting into the early parts of July. By the middle of July, we tend to moisten up enough in the low levels that as the precipitation is falling down through the base of the cloud and below that, it's not evaporating quite as much. So we get the wet microbursts in July into August. And then as we exit the monsoon season, there's a very quick drop-off in our rates of wind events towards the beginning of September and certainly towards the end of September. Now, just as a kind of a temporal climatology for you folks here, in the Tucson area, southeastern Arizona, our downbursts tend to occur between about 3 and 9 p.m. in the afternoon and evening, with the peak right about 6 or 7 o'clock. It's a little bit later for the folks up in Phoenix, and they're not really typically downburst-like because all these downbursts tend to congeal into what we call outflows, and they get sent up towards the Phoenix area a little bit later during the overnight hours and the later evening. So that's just the general overview of kind of how things work out here in Arizona, at least in terms of downbursts and wind.
Now, I want to talk about that because you mentioned the evaporation during the early part of the monsoon season, where we're still dry underneath the thunderstorms. I think most of us either have evaporative coolers in our homes, or we know somebody who does, and we know that what we do is we pull in the warm air from the outside. We kind of moisten it up, and then as we're evaporating that air as it comes into our homes, that's that cooling effect. And I think most people understand that warm air rises and cold air, so the opposite of that, the cold air would sink. So as that rain is falling out of the bottom of the thunderstorms, it's actually, since it's still dry below the thunderstorms, you tend to get this evaporation effect, and that cold air tends to make that air fall even faster, and it actually begins to accelerate, which gives you more evaporation, and it gets just going faster and faster. It falls as it falls to the ground.
Absolutely. Yeah, and as Jim mentioned earlier, you can get easily above 100 miles an hour in some of the strongest downbursts. I think we recently had a downburst hit a train up at Picacho Peak last year at ahead of Odile, and that actually derailed about 39 train cars out of the 150
Wow.
or so. They were empty, so they're a little bit lighter than normal, but just a total broadside hit just knocked them right off the track.
Oh, wow. Megan, up in the mountains, do you guys see as many downbursts, or is that an issue for you since you guys are a little more at elevation?
Yeah, good question. We do see downbursts. We do see wet and dry downbursts and microbursts. It's more common in the start of monsoon season that we see more of the dry evaporative cooling downbursts. And I wanted to mention a point up here that's of particular concern during that time of year is wildfires. And so we often have wildfires at the very tail end of wildfire season that we're watching for potential outflow winds from early convective activity during the monsoon. So that's kind of a really crucial time period for us, is right as wildfire season is ending and monsoon season is ramping up, we're often really watching for those outflow winds. And then as the moisture continues to deepen, we get into more of the monsoon pattern. We see fewer and fewer of the downburst winds, but in a strong enough storm, with the right precipitation loading, we can see wet microbursts too. So we do see them, probably not as frequently as the Phoenix or Tucson areas and the lower desert areas, but we do see them, and especially early on in the season, we're watching for wildfires. That's kind of our biggest threat with the downburst winds, is watching any wildfires in the area.
Now, we actually did mention that yesterday when we were talking about lightning, because lightning can, especially dry lightning, starts those fires, and we specifically mentioned the Yarnell fire. Of course, that was one that lightning started fire, but what actually killed the firefighters was, I believe, the outflow winds from a thunderstorm kicked up the fire rapidly and trapped, I believe it was 19 firefighters. Is that correct?
Yes, yeah, that's correct. Yep, and it was outflow driven from convective thunderstorms up on the higher terrain where we are here towards Flagstaff. We call the Mogollon Rim, and it was outflow from thunderstorms that dropped down off of the rim, and the winds really accelerated as they dropped into the lower elevations where the air was a lot warmer and drier. So yeah, that's exactly what happened during the Yarnell fire.
Wow. Hey, I see Jessica's back. How are you doing, Miss Jessica?
Good. Sorry, guys. I had to step away and handle some fire weather spot issues.
That's okay. I hate it when work gets in the way of work sometimes.
It happens, you know.
Hey, but we appreciate your hard work. Hey, you guys have Phoenix Sky Harbor Airport, which is I'd say a pretty busy airport. Do you have any concerns, or have you had to work with them as far as microburst and downburst potential during the late summer or into the summertime, or the early summer into summer, as you're going on into the monsoon season?
Definitely, it's a hazard that they're well aware of. We brief them, both the Airport Authority, which is the City of Phoenix, as well as the FAA. They're very aware of the issue. It's something that we're always kind of briefing them, and it's escalated to the point where we actually issue specific products for the airport in terms of winds, airport weather warnings. So it's for the aviation users, and they really are concerned about those downburst winds because it can rapidly change in direction. It can cause problems if there's an aircraft on approach or if there's ground equipment that's not secured. So winds around the airport is always an issue, but definitely a heightened threat during the monsoon when it comes to downburst winds.
Very good. That's what I figured. And then out in Southern California, again, you don't think of Southern California as a hotbed for thunderstorm activity. But Alex, do you guys, your kind of issues that you have to work with downburst winds?
Yeah, we have a couple good examples just last year. We had thunderstorms that occurred during the monsoon in an area called the Elsinore Convergence Zone. It's where the winds collide together, coming in from the ocean and around the mountains. And it's near Riverside, California. And once we get tropical moisture into there, like in the monsoon, we can get some big thunderstorms in that area. We had storms that were 60, 70 mile per hour downburst winds, like you talked about, that big heavy water balloon that collapsed over Riverside area. And there were 40, 50-foot trees that fell on vehicles and did a lot of damage. So it was the real thing. And then just a week after that, we had a similar event in San Diego near Montgomery Field, which is a small, relatively small airport. It takes about 600 small planes a day. It had downburst winds from a microburst, just like you showed in that video. It looked exactly the same. And there were about 10 planes that got literally flipped over from those winds.
Wow. Hey, either Carrie or Jim, could you guys talk about some of the microburst potential, the downburst potential in New Mexico that we see?
Well, there's a lot of potential for it out here, and what was the guy? The gentleman over in Tucson. I'm sorry, I forgot your name. But great example about how early in the monsoon we have better chances for the dry microbursts. And then as the lower parts of the atmosphere start to wet up, maybe mid to late July around here, then we're going to have the much better potential for the wet microbursts. Now this year has been interesting already because, as somebody else to our west may speak of, we've gotten some remnants of tropical systems that have died over the Baja California area and brought a lot of moisture into the southwest U.S. And so late May and early June have already been very interesting for this region, very unseasonal. Very
good. Lance or John Fawcett, what are some of the kind of threats to aviation? Is it small planes? Is it big planes? Is it commuter planes? Is it jets? Is it propeller planes? Who's most at risk from these downburst winds?
I would say the small aircraft, all aircraft in general can be impacted by downburst winds, but the smaller aircraft are going to be most susceptible to being impacted by these winds, especially as they're approaching landing in El Paso or anywhere really. When they're descending, they're at speed, and so when they hit these outflow winds, they'll feel quite a bit of disturbance in the flight. And that's the smaller planes are going to be more impacted by that.
Yeah, up on the screen. Hey, Jim, can you see what's I got on my screen here? Could you kind of describe what the plane's going through as it's trying to take off into a microburst?
Yeah, sure can. So as you're saying, you have an aircraft that is taking off, and it's slowly gaining altitude as it lifts off of the runway there. And then in this particular example, you have a strong downdraft that's ahead of the airplane, and so that is going to impact the aircraft from above and begin to push it down to the ground. And for certain situations, that can cause a pilot to overcorrect and cause a pilot to actually lift the nose quite high into the air to try to get some altitude as it's being forced down towards the ground. And this can be a big problem because it can result in a stall of the aircraft where there's no lift under the wings to keep the aircraft in the air, and an aircraft can easily crash because it's lost its lift, and it just with no lift, and then also, again, the winds coming from above easily take them down to the ground. So very dangerous situation.
Well, now, one of the things that I did understand with the downburst many times is the plane flies into the downburst. It can actually be flying faster. It can lift it up higher, and then as it gets to the and then, like you said, it starts to push it down to the ground, but then it actually gets a real sharp tailwind, and then, like you said, that cuts off the lift from the plane, and instead of it even though the pilot tries to gun the engine, there's no lift under the wings, and it continues to sink down to the ground.
That's right. It's just a bad situation all around. You just don't want to be in the middle of one of those things.
All right. Let me see if you can kind of describe. Let me show this video that I have here. So let me put it on me. And what we'll do is it'll be this animation of a downburst that we I think they did for. Let me change here to. Okay. So this was from the Weather Channel or from the Smithsonian Channel. But you can see as the plane flies in, it starts to get forced down. And then on the back side of it, it gets pushed down, and then the tailwind go ahead and pushes it on down into the ground. So it's and this, so Jim, correct me if I'm wrong, but downburst really came to notoriety when what was it? The Delta Airlines plane crashed in. I believe it was at DFW. How many years ago? Several years ago.
I think it was 1984, and it was at DFW, and it was one of those. It was a situation where there were a line of aircraft on approach to the airport, and a thunderstorm formed right over one of the flight paths into the airport. And this one particular aircraft that was coming in for a landing, there was an aircraft ahead of it, and it was able to get through the thunderstorm because the downburst at the time with the thunderstorm was weak. But as this second aircraft came in for a landing, the thunderstorm strengthened and produced more of a downburst, microburst in terms of the rain-cooled air, and that aircraft was not able to make it through because there was enough of the downrush of wind from that downburst to push the plane to the ground.
Wow, and it was I don't remember the number of fatalities, but it was a very serious situation. I did forget to mention, if you are watching, and I do thank you for watching, if you want to ask us a question, you can do it via Twitter with our hashtag MAW2015. That's Monsoon Awareness Week 2015. So feel free to ask us any questions on MAW 2015, the hashtag there. Hey, John, can you, John Fawcett, can you speak to? Well, let me ask you. We've talked a lot about aviation. Do downbursts affect other things other than aviation?
Well, yes. In fact, one thing that's interesting is it was in 1974 when Dr. Ted Fujita, who came up with the tornado damage scale, was in an aerial survey of what was then, and I guess for 30, 40 years until a few years ago, the greatest tornado outbreak in world history. But he was looking down and noticing, wait a minute, this damage doesn't look like a tornado converging towards the center. This is spreading out. What is this? And that really got a lot of attention, and that's when the meteorological community was introduced, or more attention was given to the downburst that we're talking about now, that water balloon of air that makes an impact and spreads out. Well, it can do, from that survey, you know, here's a top tornado expert, you know, he's giving attention to the fact that these can do damage like, you know, at least the weaker to moderate tornadoes. So it's a good thing we're talking about downbursts for the general public as well as aviation. And, you know, when there was a severe thunderstorm warning issued and a threat of damaging winds, most likely going to be a downburst, you need to take the precautions that you would in the event of a tornado. You need to get into a strong shelter, be on the lowest floor away from windows, because flying debris is going to be your #1 enemy in the event of a 70, 80, 90 mile per hour, 100+ mile per hour gust of wind. And the strongest wind ever measured in our county warning area was from a downburst, a larger one, a macro burst, back in August 1998, back when Jim Reynolds worked at our office, and 112 mile per hour measured wind. But how many have occurred between the official anemometers, measuring sites, that may have been stronger in all of our areas that are represented here?
Hey, John, up on the screen you've got a picture of a tree fall due to downburst winds. Can you kind of see it and describe what the wind pattern did there to these trees with the arrows?
It looks devastating, and that impact of the air, it made impact with the ground. You'll see the arrows there. They're not all going straight. They're diverging. and that's what the downburst does. It's that air making impact and spreading out as it makes impact with the surface. And what's so dangerous to aviation, as Jim already described, is it makes that impact and starts curling up, and it's bad enough for the general public, and it's potentially deadly, but to aviation it is just on another level of danger. And that's why I'm glad we've had Jim Reynolds here to address that issue, because it's something he has to deal with all the time.
Hey, Jim, if you were to talk to not an airline pilot, but a general aviation pilot in a smaller plane, what would you tell them? What would be safety things for them to do to avoid this situation?
Well, I would have to recommend that, of course, any pilot that's going to consider going out on a day with thunderstorms, they get a thorough weather briefing, either from somebody at the National Weather Service or maybe a self-briefing on the internet, to try to get an idea of how widespread and long-lasting thunderstorms may be when they decide to take a flight. If there's going to be too many thunderstorms over an area, then the flight shouldn't attempt it at all.
Right, right. If they're in the air and they're approaching their airport and they see thunderstorm activity, what would be your best bet? I mean, once they're up, should they just fly around and circle for a while to avoid it, or should they try to get down as fast as they can? Or what would you suggest then?
No, I would go with your first general statement there, that they should take some time to avoid being on the ground, let the thunderstorm pass, and let any kind of downburst winds come out of the storm and dissipate across the land before trying to make a landing. I've heard cases of where people do try to beat out an outflow of wind, and you're really taking your life in your hands when you attempt something like that, especially in a very light aircraft that can easily be affected by winds, and flipped over like Lance was talking about. Especially when an aircraft is not secured, it's easy to lift it up off of the ground and flip it over and cause injuries and or death to the pilots.
Yeah. Wow. Now, one of the challenges with downburst is trying to forecast and trying to let people know that they're going to occur. And one of the problems is that many downbursts occur in what we call these garden variety thunderstorms, and it can be very difficult to know, exactly where they're going to pop up more than 30 minutes, 45 minutes ahead of time. But I do know, and I think maybe Lee, you could comment on this about how we have some new models that we're attempting to look at and to test that can kind of give you an idea of on a day when you might expect to see downbursts. Is that right?
Yeah, absolutely. That's correct, Tim. And there's been a lot of tremendous improvement and strides being made. This is in the last 5 years or so in high-resolution modeling. I know one model that we rely on heavily here at this office, and I'm sure you folks do out there as well, is the high-resolution rapid refresh. It runs every single hour at very high resolution, satellites radar data. And we noticed from this past event yesterday, we actually did have some borderline severe storms in our area. It was able to capture the general idea of where thunderstorms were going to initiate, where they might move and propagate. And that kind of gave us a heads up the night before the morning of about where we should really be keeping a lookout. And then as we got closer towards the event, obviously just focusing more on the trends and the radar data. But you alluded to it earlier. It's a lot of times we get damage from these what would appear to be garden variety thunderstorms. At least now in June, it's so dry underneath these cloud bases that this evaporation effect, the cooling, the rapid acceleration can create some tremendous wind gusts from things that otherwise wouldn't look severe for the most part.
Now, anybody else, is this one of your more difficult things to when you're working the radar, when you're trying to figure out, is this thunderstorm going to have a microburst? Or is this thunderstorm just a run-of-the-mill one? Is this one of the more difficult challenges that you guys face? And anyone can just hop right in and answer.
One of the challenges we have is we'll see it on the radar, and it'll become very strong quickly. And that's a small opportunity, maybe 10 minutes or 15 minutes that we have before it collapses, and it produces all those winds. So we're talking a total amount of time that might only be 30 minutes, 40 minutes.
Another challenge is when you have those sneaky days where you already have in the background a 30 to 40 mile per hour wind, a thunderstorm develops that doesn't look that strong, but its downdraft is added to that existing momentum of the wind, and it doesn't look that strong on radar, and yet you end up with a 60-mile-per-hour wind gust, which by definition is a severe thunderstorm. That is very difficult to deal with.
Yeah. Now, Jessica, I know that it's not maybe when we're going to talk about it more tomorrow about these the dust storms that are kicked up by these thunderstorms. I know that Phoenix has in the last several years has had several rounds of very impressive-looking dust storms as they came across the metropolitan area. Are you guys getting a better handle on seeing those coming, or trying to get those forecasted ahead of time?
Well, similar to what Lee said, the idea of utilizing the high-resolution models, that can definitely give you an idea of where, like in the ballpark, where convection or storm activity might fire, and then allow that outflow boundary, those downburst winds and storm outflows to propagate possibly over open desert areas and pick up that dust and then move into certain areas like the Phoenix metropolitan or even along the I-10 corridor. So we definitely, they go hand in hand, and so you start to see, you kind of asked about referencing, how difficult is it to forecast these. If you start to see a trend early on that you're realizing, okay, this is happening with storms today, they're dropping their downburst winds, maybe additional storms are propagating or forming along those outflow boundaries, also picking up some dust as they move along. It can really become a multi-hazard or multi-threat event, given how much rain might be out there to help damp some of that dust down.
And we'll talk more about dust storms tomorrow when we do our hangout. So feel free to join us tomorrow as we talk about those. And I'm sure we'll be able to show some really cool pictures from the Phoenix area. Well, John, could you real quickly go over again some of the safety rules for downburst winds for people in their homes or just not necessarily pilots who could be impacted by this?
Okay, well, the general public. If you want to be in your home, especially if it's a strong shelter, and you want to be away from windows, and you just want to wait it out. Some of these stronger downbursts are going to be like lower-end tornadoes, so perhaps you want to follow those safety rules, be in a smaller room without windows. And motorists are also affected, and it's not just the dust storms that result from these downbursts, though that's probably the worst threat. But just imagine, driving especially a high-profile vehicle and you get side-smacked by a 60, 70-mile-per-hour wind. That could topple your vehicle. So you don't want to be driving in that situation as well. Wind has a lot of force, and so you want to treat it as such. Be indoors in a strong building, and try not to be driving. Those are some things that come to my mind right off the top of my head.
Right, and I guess that this would even apply more so for drivers of high-profile vehicles, like not necessarily the big SUVs, but the bigger vehicles like the RVs or the 18-wheelers.
And then again, maybe another really sensitive area is going to be those out on their boats on a lake. The capsizes that take place are too common, so you don't want to be out on a lake.
Very good. Well, we've gone about a little over 30 minutes, which is what we try to keep it at. Does anyone else want to throw anything else out for tonight as we talk about downburst winds?
Tim, are there any questions on Twitter?
I didn't notice any. Again, if you do have a question, it's hashtag MAW 2015. So I haven't seen any of them come in yet. So let's just go around the horn here real quickly to wrap things up, and I'll keep an eye and see if we get a real quick question here at the end. Jim, what are some last-minute thoughts on downburst winds, especially as it applies to aviation?
Well, again, if anybody's going to think about flying on a day when there will be thunderstorms, best to be very in tune with what is forecasted in terms of thunderstorm coverage and intensity, duration, because there are plenty of days I won't fly if it looks like it's going to be very active in a widespread area. That's really the best thing you can do. Just otherwise, If you own an aircraft, you would want it to be tied down or hangared to protect it from the downburst winds. Kind of what Lance was alluding to earlier is you can get very strong winds that bring a lot of sand, and that can actually get into all kinds of cracks and crevices in aircraft. Engine compartments, none of that is good. So you want your aircraft sealed up and put away, tied down, and you should be in good shape.
So the threat to aviation isn't necessarily when the plane's in the air, but it's just sitting on the ground because the winds come up and pick it up. It's still a big airfoil, and the wind can just pick it up and flip it over pretty easily.
Absolutely, you couldn't have said it better.
Wow, that's very interesting stuff. Well, let's see, Miss Megan, do you have any last-minute thoughts?
Yeah, I would just say up here, where we have a lot of mountainous terrain, it's just important to remember that we do get downbursts. They may not be as frequent as in some other areas of the Southwest, but we do get them, and it's important to remember that even in the early part of the monsoon season, when it's more of a dry microburst threat, we get them during the heart of the monsoon season too. So important to remember that with any thunderstorm that develops out there, downbursts are a threat, and just be aware of what to do. Get to a sturdy shelter. Make sure you have a plan if you're outdoors.
Very good. Now, I think we touched on it. Who could real quickly kind of give us a quick micro definition between what's the difference between a dry microburst and a wet microburst? Who wants to take that one?
Oh, that would be Jessica.
Okay. So the difference between a dry and wet microburst, we think about the dry microburst is just the colder or the rain-cooled air coming out of the cloud, but there's actually little to no rain associated with it. So all you're seeing are the wind impacts at the surface. With the wet microbursts, they're usually a lot more visible, at least if you're observing the storm from far away. You can kind of see them come out of the cloud, and the rain-cooled air, the dust kind of move with the outflow. But wet microbursts obviously imply that there's some kind of precipitation falling from the sky as well. So typically you see rain, sometimes very heavy, underneath those microbursts or downbursts as well.
Now, John, I just got a question in on Twitter from Marcus, and he wanted to know if El Paso's had a downburst or microburst, and about how strong were the winds.
Well, if you can see the radar right there, we have 2 severe thunderstorm warnings. There are several of them moving right down towards El Paso. We may see some this evening. We already have in our area. El Paso, just like anywhere else in the Southwest, is susceptible. Well, we've had wind damage that, based on the damage, we've estimated 70, 80, 90 miles per hour. You think back to a couple of years ago in Elephant Butte Reservoir, 90 miles per hour. Yeah, that's what I'm showing them. Okay, west of here, about 60 miles or so, near Columbus, New Mexico, estimated 90 mile per hour from the wind damage. So, and then not far from our office here, knocking down a lot of trees that have been up for decades at El Paso Country Club golf course. And one tree fell on a car a lady was in, but it didn't smash her part of the car. 70 mile per hour winds. Folks, anywhere in the desert Southwest is susceptible to this. It's something that you need to pay attention to when severe thunderstorm warnings are issued.
Very true. Lee, do you have any final words?
Yeah, just for the folks in southeastern Arizona, this is our high time for the dry microbursts, and we'll soon be moving into our time for the wet microbursts. And certainly, it doesn't mean we can't get both on the same day. So just to stay weather aware, and like John mentioned, heed those warnings when they come out. And one other interesting point that you don't really think about a whole lot: if you do have time, the downburst is still far away, close your garage doors. We've had numerous reports of tremendous damage to cars inside of the garage. So people just forgot to close the door. But certainly, if it's ongoing, the first thing you want to do is just get inside.
Right. That's a good thought. I had never heard of that. That it can cause damage inside of a garage if you leave the door open.
Kangaroos RWCM for bringing that one up. So yeah.
Hey, Alex, any final thoughts?
Yeah. When you're looking at the forecast, especially during the warm season, look for the wording for gusty winds or strong damaging winds, because that might be your first clue early on in the day that there's the potential. So usually what forecasters are looking at is they're looking at an inverted V, which is a lot of dry air on a weather balloon on the information we get. And they also have forecast information that'll go out a couple days showing the same thing. So they don't even need a weather balloon at the moment to be able to see that the atmosphere has the potential for strong evaporative cooling, which results in that heavy air and gives you those downdrafts. So check your forecast for those key words about the more than just a nice breeze, which we all like. Look for the strong and damaging wind wording.
While you were talking, I'm trying to find real quickly an image of what you're talking about, the inverted V. So let me see if I can pull it up here. So what we do, so people understand, is that every day or twice a day we send up a weather balloon. And what happens is that as that balloon goes up, it takes temperature, relative humidity, and pressure readings. And what can happen is that we can analyze the returns from that balloon sounding, and we plot it on a chart. And this is a kind of a simplified chart, but you can see two lines on here. The line on the right-hand side, let me see if I can zoom that in just a little. The line on the right-hand side is what would be the temperature line, and the line on the left-hand side is the. And as these lines get closer together, there's more moisture in the air. The relative humidity is higher. But like Alex mentioned, when we have this inverted V, and it's not really a V shape here, it's got a little rounded, but if you can imagine there's a V, it's an upside down V. So what happens is that where the lines are closest together is where your thunderstorm clouds form, and then as that rain falls into this drier air, you begin to get that evaporation effect, and that's what begins that microburst as it comes down to the ground. So that was a great example. Thanks for mentioning that. Anyone else with any last-minute words?
I've got something.
Yes, ma'am.
The idea that, so we're talking about how to forecast and be weather aware of these downbursts. However, we know they're also very destructive, so on top of causing problems for aviation, kicking up dust, possibly overturning vehicles, they also can down trees, power poles. So after a storm event, if you've heard that there's downburst, there was downbursts in the area, or strong downbursts associated with the radar, be careful if you're going out and about. Watch for tree branches and trees that are down, the power lines that are down. Avoid, sometimes it's difficult. You still have to travel, but just be smart of where the impact areas are, the intersections that might be impacted by the power lines.
Very true. Very true.
Very good.
Well, I want to thank everyone for joining us tonight. I want to thank especially Jim Reynolds for joining us from the Central Weather Service unit there in Albuquerque and sharing his insight on how these downburst winds can affect aviation. We also had Lance Tripoli, who's a forecaster at the El Paso office, also shared. So, and then everyone else, Alex and Carrie, Lee, Megan, and Jessica, thank you all for joining us tonight.
Thanks for having us.
That was Carrie's hand. All right, so next, I guess tomorrow we'll have another broadcast, and it'll start at the same time. And tomorrow we'll be talking about dust storms, so that should be very interesting. We can kind of continue the conversation that we had today about downburst winds, but we'll be specifically talking about dust storms and how they can impact us on the ground, especially if you're driving or living in one of these towns as this big wall of dust heads in your direction. So again, thanks to everybody for joining us today, and have a great evening, and remember to stay safe.